Well, g'day, Max here again, back in the shop. Today we're up to episode 4, part 5 of the ball turner. So the plan of attack for today is we're going to make the extension handle for the rotating unit. So I've got a bit of a sketch here. Pretty basic little handle, so we'll machine up the extension shaft and this handle. So this handle will go through the ball end and this end will fit onto the rotary table drive. So no dimensions on it, so we'll just wing it and it should turn out alright. Well, it will turn out alright. So we'll get a bit of stock chucked up in the lathe. We'll start peeling off some material. Okay, we've got our piece of material. What we have to do is be able to do this in one operation without removing it from the chuck, turning it around or anything like that. Well, we will have to remove it once, but you'll see why. We'll just face and centre drill it, and then we can put it in its final resting position in the chuck to do all of the machining. We'll just use the old faithful CNMG for everything. Okay, so we want had to remove that bit of radius from the end. That will interfere with our dimensions. So let's get a centre drill on that. Always a bit of cut and oil with a centre drill. Okay, now this will be the only time we move this during the operation. Perfect. So what we're going to do first is we're going to drill and bore the hole up the end. So it fits our handle. Oh, here we are. Here we are. So our extension will fit up the end there first. Then we'll thin down the body of it and then come back up and machine the ball at the very end. So it's all done in one operation. So all remains true to the bore. Otherwise, if you don't do it in one operation, you risk when you mount this up on this, it's going to wobble all over the place, you know. So, okay, so we need to find our size, what we've got to aim for. That was the original handle I was measuring. 8.55. So 8.5 is what we're going to be aiming for in the bore. So we might just put a, we'll go through with a 5/16 drill and we'll just bore it from there. Something I am considering is changing over to the synthetic coolant. Needs to be a shallow hole. Yeah, that's plenty deep enough. And there's the foam. Okay, we're back. Just due to that phone call, I had to take a small excursion with Bruce Witham down the road, and we had a look at a tracer attachment which I'm thinking about buying for my other lathe, hydraulically operated tracer, something along similar lines as Nick Collier's got one, and Keith Fenner has one as well. We'll see what happens with that. So on with boring this hole out. We've drilled it and we're going to bore it to 8.5. So I've just got a little high-speed steel boring tool here. Pop that in and see how she goes. Slow feed rate for this, so just back it right off. Now I can feel that tool is a little bit below centre. Just bring her up a bit. Try that. There's a story behind that tool. I ground that up to do a special job. Oh, it would have been probably the late 1980s and I haven't used it since. Let's sort of see where we are. $330.5. Oops. 333.5. Just take a whisker more out of that. I might check this with a mic. A bit more accurate measurement. $333.5, $332.5, $333. I don't have any small bore gauges that go down that far, so we're measuring here 333. So by rights, that should go in there quite, and look at that, beautiful. That's exactly what we want, nice firm fit. Just get our deburring tool and knock the sharp edge off that. Okay, so we'll put that one back in. We'll get it set up with a centre and an appropriate tool to start cutting the formwork out. Okay, we'll swap out the CNMG for a TNMG, a triangle shaped one. That'll give us a bit better profiling ability. So this is going to be all partially by eye, this piece. So we have a parallel section and we cut in, then we've got to turn a taper. Now let's do our parallel section first, and then our taper, we'll just tap the compound around it a little bit. We'll do the taper with the compound. Bring up our feed rate a bit. That should be alright for our parallel section. As I said, there's no great accuracy required. As long as we've got enough meat on there for a collar, because it's got to contain a grub screw, that'll be fine. Okay, so we will angle our compound around, bring our compound all the way back to give us the most travel. We'll start at about there approximately, I think. Might just nip our saddle down a bit. we go. I think we'll back that off to 2.5 degrees. As I said, it's all trial and error. not too bad that. Give it a bit of a chamfer on the back. Bit of a touch up with the emery paper and she should come up alright. Okay, I was just having the emery paper wrapped around the drill bit then, just to give us a round area. Just aids in cleaning up that radius that we have there. Okay, now we have to machine a ball on this end here. Starting to look like a ball. Let's angle our tool round us a little bit more. You have to turn a freehand ball in order to make a ball turning attachment, eh? Okay, should be right there. catch all the grit. Okay, we will finish the rear end of the ball with the parting tool. Hot, so we'll pick that up with a rag. We'll turn that around and we'll just tidy up that little piece on the end. Okay, there we have our finished handle extension. So what we do now is we drill a hole through this end and we make the cross piece. Well, okay, we've got our handle extension clamped in the vise so we can drill the grub screw hole there and our through hole down here for the cross handle. So we're just centralising her up in the vise now. That's just another different way you can do it. I've just got the Blake coax out. I know they're supposed to run in a hole, but if you're gentle with them, they'll be okay, you know. So we're just sweeping the vise jaws. It's on 5 there. Come round to the other side. Which is on 5 there. Beauty of using the blade is you don't have to look from one side of the indicator to the other. I mean, you can only use it in certain situations because you shouldn't have any side thrusting on the blade needles. It's not good for the mechanism down the bottom there. But, just actually, while I've got this blade on, the quill of this Chinese mill is fully retracted. Have a look at the indicator movement when I do this. Eh? How's that for precision engineering from China? So we'll move on and get our cross holes drilled. Okay, so it's time we'll get our cross handle piece made up for this. So this is our extension. So we've drilled and tapped for the 2 grub screws 90 degrees apart down this end. So we're just going to make the handle through this end. Okay, so we just clean up this end and we have to drill through for the other handle coming out the side. Well, we've completed all the major components of the ball turner, the handle extension and the new handle here. So that enables us to rotate the attachment in a controlled fashion to machine the ball or a convex radius. So that will let the tool sweep across the diameter. And to adjust the cuts, it's just the cuts are taken on this top slide here, so you can wind the tool in or out to make your depth of cut. So we just have to design a tool holder and then we're good to go. Yeah, so as the ball turner is coming near completion, we might squeeze in an interim project before we start on anything else. Well, obviously we'll finish the tool holder for the ball turner and we'll turn up a ball and maybe a concave radius as well. Emma Ritson has her tool making competition coming up, so I might put an entry into that, I think, so we'll squeeze something in for the tool making comp. So, alright, take care. See you next week. Oh, thanks to your subscribers, and big thanks too to Dan Dobbs from the House of Broken Dobbs Things for the shout out he gave us the other week. So take care.